Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. Before we get going, I'd like to send a huge thanks to LinkedIn for sponsoring today's show. LinkedIn Engineering solves complex challenges at scale to create economic opportunity for every member of the global workforce. AI and ML are integral aspects of almost every product the company builds for its members and customers. LinkedIn's highly structured dataset gives their data scientists and researchers the ability to conduct applied research to improve member experiences. To learn more about the work of LinkedIn Engineering, visit engineering.linkedin.com/blog. And now, on to the show. All right, everybody. I am here in Santa Clara at the first O'Reilly TensorFlow World Conference. And I've got the pleasure of being seated with Jonathan Hung. Jonathan is a senior software engineer at LinkedIn, and he is presenting here at the conference tomorrow. Is that right, Jonathan?
Yep, that's correct.
On your experiences scaling TensorFlow at LinkedIn. Welcome to the TWIML AI podcast.
Thank you.
Before we jump into your talk and your project, I'd love to learn a little bit about your background and how you came to work on machine learning infrastructure at LinkedIn.
So back in 2014, I joined LinkedIn as an intern on what was then called the Hadoop development team. So we handled the Hadoop infrastructure at LinkedIn for storage and compute orchestration. So I rejoined LinkedIn the next year in 2015 on the same team. When I joined, I was working on the compute infrastructure at LinkedIn, which is Yarn in the Hadoop project. So we were building some enhancements around compute efficiency, making sure we were getting good ROI on the hardware that our jobs were running on. So I worked on that for a few years.
Was this the Tony project, or is that separate?
No, so this is separate. This was Yarn specific, so nothing related to machine learning yet.
Okay, got it.
Yeah, just making sure we have Hadoop clusters at LinkedIn that we manage a couple thousands of nodes and making sure that things are running efficiently.
Okay.
There. Yeah. So I worked on that for a few years. And then in late 2017, I'd say, there was a lot of interest in using deep learning to improve the insights that we were giving our members. So we started exploring using TensorFlow as our deep learning framework. And so we were kind of experimenting with various existing frameworks in the open source world for running TensorFlow on a Hadoop cluster. We explored some projects and none of them really fit our needs exactly. So that's when we started to build this project called Tony, which stands for TensorFlow on Yarn. And so this is our in-house solution for running distributed TensorFlow on our Hadoop clusters.
I'm curious, what were some of the things that you looked at that didn't quite work for you?
Yeah, so we looked at a few options. The first one was a project called TensorFlow on Spark. So this was open sourced by Yahoo. I don't know the exact date. So the concept there is pretty similar. Instead of running your TensorFlow training and modeling code directly on your Yarn cluster, you would run it on a Spark cluster, which usually runs on a Yarn cluster. And so that worked reasonably well, but there were some feature gaps that we couldn't overcome. So at the time, there wasn't great support for fault tolerance in that project. I know since then it's improved, but at the time, this was a big blocker for us. And then a couple of other things that are related to kind of the Spark execution model. So one of them was that Spark didn't have support for GPU requesting and scheduling. And so a lot of our AI engineers, they were interested in running their distributed TensorFlow training on GPU hardware to accelerate the speed at which they can iterate. And so since Spark didn't have support for this, this was one of the big reasons we decided to build something else that we could integrate that GPU support with. And then the last thing was more related to Spark itself. So kind of the Spark execution model is, you have a driver and a bunch of executors in your job. And the problem here is that all of your executors need to share the same resource profile, essentially. And this didn't really mix well with the TensorFlow execution model, where you have various job types, such as your parameter servers or your workers and things like that. And each of these job types may require different resource profiles. And then so if you're running TensorFlow on Spark, this won't really work. And then you end up with a lot of resource wastage.
Okay.
Yeah.
And so maybe taking a step back, what's the overarching motivation for running TensorFlow on the Hadoop clusters? Is it that you have them and they're there and you want to use the machines? Is it that you like Yarn as a general kind of workload orchestration system? And maybe kind of an adjacent question, if you didn't have that existing investment, would you do the same thing? Would you stand up a Hadoop cluster and then run TensorFlow on it, or would you be going in a totally different direction?
Yeah, so I think our biggest motivation for building Tony was because we had these Hadoop clusters. So LinkedIn has invested in Hadoop as our de facto data processing platform for many years now. Even before I joined the company.
Sure.
And so, teams across our company are running very diverse workloads at scale on our Hadoop clusters. And so the Hadoop ecosystem at LinkedIn is very mature. And so we're running these clusters with thousands of nodes, petabytes of compute. And so we wanted to use our infrastructure and our expertise in Hadoop and build a way to run TensorFlow on this infrastructure.
And historically, Hadoop offered this advantage of, in the context of MapReduce, this kind of locality between your compute and your data. Does that have any relevance in the machine learning model training world?
Yeah, so ideally the model training would be bounded by your compute speed. And so hopefully I/O doesn't become a concern.
Yeah.
We have found in the past that I/O was a big limiter for us, but we don't think it was related to locality reasons.
It's just a bad model or training or something like that?
Yeah.
Okay. I've had Beechan on the show before talking about ProML. What's the relationship between Tony and ProML?
Yeah, so the idea behind ProML was to give our AI engineers a better experience for building end-to-end machine learning pipelines. So, you have your data pre-processing phase. You may be doing some feature extraction, things like that. And then you have your model training, and then you can save your model and then go on to the serving phase. And so the Tony part is kind of fills the model training part of this pipeline. And then we have some, internal libraries to link all of these systems together.
Okay. So ProML is kind of a layer of abstraction that sits on top of a bunch of things, Tony being one of those on the training side.
Yeah, exactly.
Cool. So tell us about your presentation. How's your presentation structured?
Yeah, so it's kind of a mix of the things that we've talked about, kind of the Hadoop ecosystem at LinkedIn, what that looks like, and then kind of going into the story of why we were looking at TensorFlow as our deep learning framework, and kind of what the experience was like for our AI engineers in running either single node or distributed TensorFlow back in 2017 when our deep learning infrastructure was not very mature. So talking about what that experience was like, some of the gaps that we saw.
Well, let's maybe pause here. It sounds like you have some interesting stories there. What's the kind of what did that world look like, and how does that contrast to how it looks today?
Yeah, so I think the biggest gaps there were users would have to, like AI engineers would have to set up their own training environment, either locally or on machines that we provided them. And so there wasn't really like a set of managed compute hardware that people could run on.
Mm-hmm.
So it was kind of like a free for all Wild West sort of situation. You have all of this compute hardware sitting there, but there's nothing to manage it.
Right.
So it kind of ends up being the user who has to figure out, which machines are available. Then you run into like race conditions where, I see this machine is available, but someone else does. And then you end up kind of butting heads.
Okay.
Yeah. So that was the biggest issue. And, especially with like GPU hardware, this becomes an even bigger issue because you only have so many GPUs on a single machine. And you end up running into multi-tenancy issues a lot,
right,
which is what we experienced.
Yeah, the race condition issue is that's an interesting one. I hadn't thought about that particular example of you've got some shared resource and two people see it and want to take advantage of it, and then they spin something up and now they're colliding.
Yeah, exactly.
Right?
Someone wins, but the other person loses.
Right.
So
right,
that's just
right,
a really bad experience.
Yeah. And so today obviously is more of you've got a set of shared services that developers can take advantage of, and TensorFlow is a big part of that.
Right.
And why TensorFlow? Any particular thoughts on why TensorFlow as a framework, was the right direction for you?
I can't really speak to why we decided to make TensorFlow the official deep learning platform for us.
And maybe the more interesting question is, one of the big decisions that folks that are trying to provide platform services need to face is whether they are offering, whether they're trying to be framework agnostic and support everything, or whether they are focusing on a particular thing. Is it correct to infer that there's a strong focus on TensorFlow for LinkedIn to the exclusion of other frameworks, or do you also have ways of supporting, you're just here talking about TensorFlow, but you also have, PyTorch on Yarn or something.
Right.
Pony?
Yeah.
Pony's a good.
Yeah. So this is actually something, it's kind of interesting. When we first developed Tony, it was for TensorFlow specific support.
Okay.
And this was mostly guided by our AI teams who were most interested in using TensorFlow.
I mean, there was certainly a period in time in which TensorFlow was the only choice that made sense.
Right.
Right.
Yeah. And so, I think right now we are not really platform agnostic.
Mm-hmm.
We, as a policy, I'd say we only support certain frameworks. And I think that's maybe an easier way to scale our deep learning infrastructure. We only have so many infra engineers on our team that can support these frameworks. Right. So we kind of need to limit what kind of the support we provide to the engineers at our company.
Yeah. It's interesting. We earlier this month had a conference, TWIMLCon, focused on TWIMLCon AI platforms, to be precise, focused on the platforms and technologies that folks are standing up to accelerate machine learning. And you hear a lot of people kind of advocating for, you have to support, in platform roles, you have to support everything that the engineers want to use. And it's, I think, worthy of pointing out that if an organization, that's with an engineering culture like a LinkedIn, and, the size and scale of LinkedIn, both in terms of engineering team and problem, can say, well, we're going to focus on this.
Yeah.
Then there are probably a lot of other organizations that are smaller that can also do that and probably get as much advantage, of focusing on something, whether it's TensorFlow or PyTorch or whatever.
Yeah, exactly. I feel like, if you have a team of hundreds of engineers that are working to support deep learning at your company, that might be something that's possible.
Meaning just on your platform team.
Yeah.
Not developing
No.
deep learning. Right.
Yeah, but we only have so many people on our team that can only do so much.
Right.
And so I think this is the best way for us to do it.
Yeah. Okay, so you were talking about the motivation for this investment and the experience that engineers had before this project. What's next in your kind of agenda or your story on this with the presentation?
So after we go into kind of the gaps that we saw in distributed TensorFlow training, we'll talk a little bit about how Tony works behind the hood. Mm-hmm. So kind of what features we support, how it's implemented on top of Yarn, and then kind of how AI engineers at LinkedIn would use it. And so that part will kind of go into like coming back to the pitfalls that we saw, how Tony addresses them, basically.
So walk us through that.
Yeah. So do you want like a walkthrough of how Tony works? Or
yeah, absolutely.
Okay.
Absolutely.
Yeah. So sort of for any Yarn application, there's a few main components. There's a client component that is submitting jobs to your Hadoop cluster, and then there's what Yarn calls an application master. So you can think of this as essentially a driver that handles all of the subtasks in your Hadoop job. Mm-hmm. And then you have what Tony calls a task executor. These are essentially the tasks that are doing the heavy lifting in your job. And so for us, we have implementations of all three of these components, and then we package them all into this Tony library. And so some of the things that we've built into the design of Tony, most of this is happening in the application master, or the driver. So some of the things that we need to support are like fault tolerance, which we talked a little bit about earlier. So, as our engineers are running on more and more training data, their training may be running on more workers, running for longer. Mm-hmm. There's this idea that any machine can fail at any time, mm-hmm. which will cause the tasks running on that machine to fail. And so we needed good support for fault tolerance in the Tony framework to make sure that if we run into these transient issues such as hardware failure, that Tony can transparently continue training and make sure that the job succeeds to completion. Mm-hmm. Yeah.
Now, in the Hadoop world, there's, people will say fault tolerance and mean lots of different things, right? Yeah. They could mean that a node fails, but there's been checkpointing happening during the training or the job, and so some other node is able to access that state and start or continue, and not have to start back to the beginning, or you said kind of continuous, fault tolerance, whereas or such that there's no interruption at all, there's no checkpointing that needs to happen. Those are maybe the spectra of different, ways that people use fault tolerance. What level of fault tolerance are you providing, and how are you providing that?
Yeah, so I think for frameworks like MapReduce or Spark, it will follow this model of you may need to recompute some things, mm-hmm. And then the framework will handle exactly what you need to recompute.
Yeah.
So in Tony's case, it's a little different. So since TensorFlow already has this capability of checkpointing status to some durable storage, essentially. In our case, we're using HDFS since it's running on our Hadoop cluster.
Right.
Yeah. So for us, we're like checkpointing the status of our Tony jobs every few minutes to our HDFS clusters. And then in Tony's case, if it detects that some worker has failed for whatever reason, it can tear down the Tony application, all of the workers associated with it, and then re-request resources from the Hadoop cluster, spin up the same job, but read from the checkpoints that were saved from the previous attempt.
We spoke earlier about this race condition issue. Does Tony kind of inherently solve that race condition problem, or is it just that it organizes everything in some higher level abstraction like ProML, like a scheduler of some sort with a user interface can better handle that race condition?
Yeah. So I think the core problem with having these unmanaged machines and thus the race condition is that there is no layer that is aware of which machines have how many resources and how many are being used, right? And so we kind of got this for free, so to say, when we moved to managed infrastructure like Yarn. So, when we want to build end-to-end GPU support for our users, we need to make sure that every layer in our stack is aware of these GPU resources so that we don't have this race condition. So for us, that meant, in the Yarn layer, Yarn needs to know, you have all of these machines in your cluster, how many GPUs are on each machine. When a user runs a task on one of these machines, how many GPUs is it using? And so Yarn is aware of all of these things. And then so we can leverage that in Tony. And Tony can say, this user requested 2 GPUs. I'm going to ask the Yarn cluster for 2 GPUs. And then the Yarn layer can handle the scheduling part for that.
And so that was the kind of how it works element. And we covered some of the problems that it fixes. Are there others that you highlight in the presentation?
So the fault tolerance issue and the GPU issue, those are the 2 that we cover. Okay. There are a few that we decided not to get into. So after that, we kind of start to go into, this is useful for scaling up TensorFlow training at LinkedIn, but we also have this orthogonal issue of if AI engineers want to experiment on new libraries that came out in the open source world, how can they easily experiment on that? Mm-hmm. And, if you've ever worked with Hadoop, it doesn't lend itself very well to experimentation, I think. And so one thing that we were exploring was building a Kubernetes research cluster that our engineers could use to do various experimentation. And so one of the powerful things about Kubernetes is that there's very good support for containerization. So if our engineers want to use some library, they can easily build the image themselves and run it on the Kubernetes cluster. Mm-hmm. And so the later part of the talk will get into kind of how we built that out, some of the gaps that we saw when we were building out our Kubernetes cluster, and some use cases.
Okay. And just to be clear, the Kubernetes cluster is independent of the Hadoop cluster, or are you somehow running Kubernetes on top of Hadoop?
Yeah. I know there have been some attempts.
There have been some attempts.
Yeah. We decided not to go that route.
Okay.
So essentially the Kubernetes compute part is a separate cluster.
Okay.
And this is something we'll get into in the talk as well. We already have this vast data lake on HDFS with all of our training data. Mm-hmm. And so even while we have this separate compute cluster for Kubernetes, we want a way to access this data lake. So this is one of the gaps that we saw when building out this Kubernetes cluster. How, if people run these Kubernetes jobs in this cluster, how do they access this data? Since we're running secure Hadoop, it's kind of non-trivial to instrument this. So that's something we also get into in the talk.
And so the main challenges there are kind of integrating in with the kind of your access controls and entitlements on the Hadoop side, and the kind of the file system driver infrastructure on the Kubernetes side, or is it something else?
Yeah, that's basically what it does.
Okay.
There's built-in support for accessing a secure cluster. How do you authenticate and things like that when you're running your tasks on the Hadoop cluster? But then when you have some external cluster on Kubernetes, how do you do the same thing? And so that gap is something we had to bridge.
Well, before we dive a little bit deeper into the Kubernetes side of things, does Tony take advantage of or draw from any of the other distributed training approaches for TensorFlow, the built-in distributed training or Horovod or any of those kinds of things? Or is it, as part of what you did, kind of build your own version of that stuff?
Yeah, so the layer at which Tony operates at is kind of on top of the TensorFlow distributed training part.
Mm-hmm.
So when an AI engineer wants to run distributed training, they're writing the model creation and the training logic themselves. So if they are interested in running some distributed training strategy, they can do that. And then Tony is kind of a thin layer on top of that, which will handle the resource acquisition and task launch, essentially. And then once that part is complete, then the AI engineer's distributed TensorFlow job will proceed as it normally would.
Got it. And so some portion of your user community is coming in, their jobs are being submitted via ProML, but I'm imagining some are using Tony directly. And if that's the case, I'm curious what the user experience is. Are they creating Tony YAML files or
Yeah, so kind of the bare bones Tony experience is you need to create your configuration files.
Yeah.
And then package all of your source code and everything yourself.
Like jar files or something.
Right, exactly. Yeah. So if you're running Tony from the command line, for example, that's something we would expect the user to do. But at LinkedIn, we have this ProML ecosystem, and the objective there is to provide a higher level abstraction to our engineers. And so a lot of these nuts and bolts are kind of handled for them.
Cool. Well, maybe let's take a few minutes and talk about how you're approaching Kubernetes. I guess, first of all, are you, is there an official position this is the future of the future direction for, distributed compute for ML and AI at LinkedIn? Or do you see Kubernetes and Tony coexisting long term?
Yeah, that's difficult question for me to answer. I think we are, the Kubernetes work we're doing is still pretty early phase. And so I think as we onboard more and more use cases, we'll see what the gaps there are. And then I think at that point, we'll have a better idea of what the long-term distributed TensorFlow story will be at LinkedIn. But as of now, the state of Kubernetes at LinkedIn is, we're still building out the infrastructure, and we don't really have a solid idea of how that plays into our long-term solution.
Beyond the challenge of the security challenges that we talked about, integrating at that level, these two disparate systems, what are some of the other challenges that, challenges, or what are some of the other, focus areas that you're doing to kind of make this Kubernetes cluster accessible to folks?
Yeah, so I think the the HDFS access thing was the biggest thing for us. And then for experimentation, we're still kind of experimenting with it within the infrastructure team. And so a lot of the issues are related to building out the actual cluster and making sure that it operates as a production cluster should. So, for example, making sure that the nodes in our cluster are up most of the time and making sure that we have appropriate metrics and monitoring to accurately assess the state of our cluster. Yeah.
So it's kind of core Kubernetes operability stage that a lot of people, frankly, are at. As opposed to how do we build some higher level abstraction on top of Kubernetes that is ML focused or creates the user experience you're trying to offer to your ML engineers.
Right, exactly. Okay. Yeah, I think once we, solidify the Kubernetes infrastructure, then we can start onboarding more and more users, and then hopefully it'll take off from there.
Mm-hmm. Mm-hmm. And it sounded like you have a few research-focused teams running on Kubernetes now. Are they doing? Are they kind of experimenting? Well, I guess experimenting is overloaded, but are they like running real use cases and workloads on this? But maybe not time critical ones, or like how do you characterize how you've started, in terms of a workload perspective on the Kubernetes side?
Yeah, for now it's mostly kind of on an ad hoc basis. So people aren't really running, critical jobs there.
Yeah.
And we've kind of played with some use cases, such as running Horovod on Kubernetes, or running Kubeflow, for example. Mm-hmm. But yeah, those are still very experimental. So,
did you cover anything beyond the Kubernetes stuff, or was that where you left it? Presentation.
I think that's the last thing that we cover. Yeah.
Okay. I asked a little bit about the kind of the future of all this at LinkedIn with respect to Kubernetes and Hadoop, but more broadly, what are some of the things that your group is looking at going forward?
Yeah, I think right now it's really important for us to give our engineers a really good user experience. A lot of our work so far has been making sure our clusters can scale well as we add more machines and hundreds of users are onboarding their deep learning jobs. But we're always trying to improve our user experience. And so that's something we'll be addressing in the next few months.
And are there specific aspects of that you can talk about?
I'm not sure how much I can say. A lot of it is related to, for example, like internal tooling or the way our clusters are built out, for example.
Got it. So even if you could say, it wouldn't mean much to anyone.
Yeah.
Cool. And I'm curious if you have any kind of going back to kind of core TensorFlow, any kind of interesting lessons learned or, things that you would share with folks that are, starting to think about, building out platform support around TensorFlow, key things that it was important for your team to learn?
Yeah, so far, I think just using what the open source TensorFlow community has provided has worked reasonably well for us. And I think when we cover, for example, Tony in the talk, it kind of sits on a different layer from TensorFlow. Mm-hmm. So up to now, we haven't really had to delve into the TensorFlow internals. But in the future, I think as we optimize model training more and more, that's something we're going to look into. How can we better optimize the actual TensorFlow layer rather than the layers that sit on top of it.
Well, Jonathan, thanks so much for taking the time to chat with me.
Yeah, thank you. It was a pleasure.
All right, everyone, that's our show for today. To learn more about today's show, including our guests, visit TWIMLAI.com. If you missed TWIMLCon or want to share what you learned with your team, be sure to visit TWIMLCon.com/videos for more information about TWIMLCon video packages. Thanks so much for listening, and catch you next time.